Thank you for supporting Hot Science and Hot Science Cool Talks. You help share exciting research and discoveries with the world. From a pen designed to diagnose cancer, to technology that can predict flooding, to the origins of the universe. But most importantly, you help spark K-12 students to go into the sciences. And you improve science literacy among adults, making the world a safer, healthier place. Look for Hot Science on national TV soon, and catch Hot Science Cool Talks live and in person on UT's campus. Thank you for your generous donation.
Thank you indeed, and welcome everyone to Hot Science at Home. We're so glad you could join us tonight. UT Austin's Environmental Science Institute is proud to bring you the latest and coolest advancements in science through Hot Science at Home. And we'd like to welcome everyone watching on YouTube and Facebook. Great to have you here. So it's my pleasure to introduce tonight's guest, Professor Joe Levy from Colgate University. Welcome, Joe.
Great to be here, Jay.
Joe got interested in the earth and in science as he spent time outdoors, or in the field, as we say, when he was growing up in Maryland. And as we'll see, Professor Levy's field areas are now in some very, very extreme environments. Pleased to inform you, Joe recently received a prestigious award, the Career Award from the National Science Foundation, which basically means he's really good at science. Welcome, Joe. Glad you could join us.
Oh, thanks, Jay.
Yeah, we encourage you all out there to enter your questions at any time, and we'll ask as many of them as possible during our Q&A with Professor Levy right after the presentation. You can submit your questions through Facebook or the YouTube comment section. So Joe, tell us about yourself. Just what kind of scientist studies Mars?
Well, I'm a geologist, and that makes sense. Earth is a rocky planet. Mars is a rocky planet. But don't tell anyone I'm actually not that into rocks. I'm actually the kind of geologist who's way more interested in ice and sand and even mud. And what I really want to know is, how does an icy landscape, how does a frozen landscape or a frozen planet evolve? If you're out prospecting on that landscape for ice, how would you know it was there? Where is ice distributed in the ground? And then I'm lucky enough to work with ecologists who want to know, how do organisms live in frozen landscapes? How do they use that ice and rock and mud or salt to create a habitable environment where microbes can survive?
So where does your research take place then?
Well, I'd like to work on Mars, but the commute is pretty awful. And so instead, I work in the most Mars-like place on Earth, which is Antarctica. And what you're seeing here is some drone footage from the last field season in Antarctica. And you might think that's a really weird place for geologists to work, right? You think Antarctica, you think ice everywhere. But I work in the McMurdo Dry Valleys. And this is a tiny corner of Antarctica, less than a percent of its area, that's not totally covered by ice sheets. So when you look out in this drone footage, you see a big, bright, icy glacier. That's one of the big ice sources. But you also see meltwater. You see little streams that come off the glacier in summer. And then all that sort of grayish, rocky soil you see is permafrost. It's frozen ground. And there's ice hidden in there. So the dry valleys are this cool laboratory that is kind of like a spaceship. You can get in there and go to a Mars-like place. But it's also like a time machine. We can actually use the dry valleys to look back into Mars's warmer, wetter history when streams like the one you see right there were flowing across the landscape, when lakes formed, like the Mars Curiosity rover is experiencing at Gale Crater. And most importantly, when ice-rich land permafrost features like that cracked ground you see in the front there form. So we want to know, where is the ice, where is it hidden, and how could either microbes use it today or future explorers use it?
So some real connections there, but what is the big overarching connection between Antarctica, Mars?
Well, I mean, Antarctica is really Mars on Earth. It's a dusty, cold, dry, salty, irradiated environment. And, this is what field work out in Antarctica looks like. So that dust being kicked up by the helicopter landing, that's me hiding there by the rock, kind of gives you a sense of like, oh, Martian dust storm. Yeah, I'm still picking dust out of my nose and ears and everything else from that helicopter landing. But it's the environment that makes Antarctica so Mars-like. So Antarctica is a cold desert. It has an average temperature of minus 18 Celsius. That's like 0 Fahrenheit. That's cold. It's dry. It never rains in the dry valleys. And when it snows, it's 3 to 50 millimeters of snow. So teeny tiny amounts of snow. And it's so dry that all of it sublimates into the atmosphere. It doesn't actually melt. It mostly just disappears as a gas. It's salty. All that snow leaves behind salt. There's sea spray, and that's kind of like salting slugs. That's torture for microorganisms. And worst of all, it's irradiated. So the ozone hole is alive and well in Antarctica. And so every summer, ultraviolet radiation comes streaming down onto this dry, dusty environment and can practically sterilize the surface. And this is Mars in a nutshell. Mars is cold and dry and dusty and salty and irradiated. So if we want to understand how landforms evolve and how habitable environments, places where microbes could live, develop, we want to use Antarctica as a laboratory. And so that's why we go.
Dry, cold, dusty, salty, irradiated. Can't wait.
Yeah, it's great to visit, but where I'd really like to go, of course, is to Mars, which takes all of this dry, dusty, salty, irradiated, and kind of kicks it up to 11.
Right on. How do we get there?
All right. Well, getting there is a little bit more difficult than just getting in a plane and going to Antarctica. So getting to Mars, we got to get to another planet. So we are orbiting the sun once a year. We've got to get out into the outer solar system where Mars is. And Mars's orbit is about once every 2 Earth years. And so there's an opportunity every 2 years or so to get on a rocket and go. So what do you need to do? You need to start going as fast as you can. Get in your rocket, blast off from Earth, slingshot, do whatever it takes to get heading out in that orbit. Then you've got to find Mars, line up. It takes only about 6 or 9 months to get there. So, a bit of a commute. Then you want to get captured by Mars's gravity and into its atmosphere and go blazing into its atmosphere. This time period from when you enter the Martian atmosphere to when you make it to the surface, NASA sometimes calls the 7 minutes of terror. You got to slow down really, really, really fast and try and stop before your altitude becomes a negative number. That's what you want to avoid, is turning into an impact crater. And only about 1 in 3 missions to Mars have done that. Getting there, just getting the rocket to be in the right part of space at the right time is hard. Surviving that entry, descent, and landing is hard. And then stopping in time is really, really hard. So it's a risky trip. But the reason you want to go is to find answers to these questions of like, is there life elsewhere in the universe? How does life evolve? How do planets evolve? And can we make it on a planet that's so cold and dry and dusty that it's like Antarctica, but more so?
So you've got a really good team of rocket scientists, engineers. You figure out how to do it and how to land it in very softly at 0 elevation, minus 0.01, let's say. How do you decide exactly where on the planet to land the thing?
Well, in the same way that Antarctica is a continent set aside for science, I'd like to think about Mars as being a planet that, is a scientist's paradise. There's so many places to go. So we're looking here at an elevation map of Mars. So red and warm colors are high elevation. You can see the Tharsis volcanoes, some of the tallest volcanoes in the solar system. You can see giant, deep purple impact craters. And there's so much science there. You could go to the polar caps and look at Mars's climate history, the same way we look at climate history on Earth. You could go to an old ancient lake bed and look for evidence of past microbial mats. Those are at the equator. You have the whole planet at your disposal. If you're into volcanoes, there's volcanoes everywhere, canyons, you got them. The problem is you can't land just anywhere, right? That stopping safely is really important. And so the first thing you want to consider is, can you line up your orbit so that you land in a place that your rocket can reach safely and where there's going to be enough power to survive and where there's going to be enough heat to survive. So engineers in general say land at an equatorial latitude. So those polar regions, they're right out. No can do. You get a Sharpie and take out the polar regions. And that's because, we want to stay someplace where the sun is shining. And so it's plus or minus about 20, 30 degrees. So Austin, its latitude on Mars would be okay. But here in upstate New York, it's right out. You also then want to pick a place that's not too high and not too low. So Mars has an atmosphere. Landing on the moon is easy. There's no atmosphere. You just fire your rockets and slow down and stop. But Mars has this very thin atmosphere, less than a percent of Earth's atmosphere. And so it's good for stabilizing a parachute. It's good for slowing down a spacecraft. But if you're too high up, there's not enough atmosphere and your parachutes aren't going to work. If you're too low, there's actually so much atmosphere. Again, it's sort of hard for a parachute to work right. So you want to rule out places that are way too high. So unfortunately, that means those giant volcanoes, the Tharsis volcanoes, they're out too. It also means the deepest craters, some of these big basins, are probably going to be gone. All right, so your parachute's going to work. You're going to have solar power. You're going to be at a nice temperate latitude. What's another obstacle to look out for? Well, you don't want to land your giant spacecraft, which is a giant tube, on something that's steep so that it tips over. And so NASA scientists and engineers spend a lot of time, picking landing sites that aren't steep. Even a couple of degrees is enough to tip over a rocket and knock it over. So we're looking for areas that are fairly flat. Unfortunately, every geologist knows that flat is sometimes a little bit boring. We want, to find places where there's scenery, where there's something to hike around. All right, other obstacles. Well, you saw when that helicopter was landing. That was my landing site on Earth. In Antarctica, and that dust was terrible. As the helicopter landed, dust went flying everywhere. Rockets are going to do the same thing. So we want sites that aren't too dusty. We don't want dust to fall out on solar panels. We don't want dust to choke our vents and things and to get into spacesuits. That's a huge hazard. So we're going to rule out places that are too dusty. The problem is we also have to rule out places that are too rocky, right? If a spacecraft is landing and it gets hung up on a boulder, that's going to tip it over. That could break it. You don't want to drive into a rock and with your car, and you don't want to drive into a rock with your spacecraft either. So rocky places, they're out. So it sounds like poor geologists aren't going to have a lot to look at. Don't worry, there's plenty to see. All right, last thing we want to do is find places that are not too shiny and not too dull. And you might think, well, who cares about that? Well, how shiny a surface is tells you how much sunlight bounces off of it. So we want places that aren't going to be cold and are going to reflect all their heat away. We also don't want places that are going to spoof your radar. So if you're shining radar waves down onto the Martian surface as you're landing, and your radar is being bounced away, your rocket isn't going to know how far above the surface it is. And that's one instant recipe for landing at a negative elevation, for crashing into the surface. So we want places that are safe for engineering, but also interesting for science.
Wow. So you get that all figured out. You've got your windows, which still has plenty of fascinating things to study, of course.
Yeah, there's a whole planet out there. We're down to about a third of it, but hey, that's pretty good. There's as much land on Mars as there is land area on Earth in terms of our continents. So a third of that we can find some great science to do.
Indeed. So you have your landing sites figured out. Now, how do you figure out what to take? What's the most important?
Well, if you're planning for a trip, you might think, okay, the important things are like clothes or some snacks or gas, and this is a road trip on Earth. What you're not thinking about when you road trip on this planet is, am I going to have enough air to breathe? Am I going to freeze? Am I going to be able to find water? But all of those things are really big problems for Mars, right? Because Mars has such a hostile Antarctic-like environment. And so on Earth, we're lucky. We can live off the land. And so even more than thinking about what to pack and bring with us, I think future Martian explorers are really going to have to think about how they can live off the land. So imagine, instead of exploring Mars, you're exploring the United States, and you've got your mule team here, and explorers on the East Coast were trying to see what was out west. And imagine if they had to take their water and their hay and their oxygen with them. Water to feed yourself and your mules, hay for I guess you if you're really hungry, but definitely for your mules. Even oxygen, right, to put a helmet on these poor little critters because they again can't live off the land. So it turns out if you had to bring all that stuff with you, you'd be so overladen that if you wanted to get from the East Coast west and then back to your landing craft, your ship, whatever it is, explorers only would have penetrated about 100 miles in from the coast. And that's really not a lot, right? Huge parts of this country would have been totally unexplored. I grew up in Maryland, and all we would know would be like, oh, where Joe grew up is a pretty good place. But we wouldn't know almost anything about Texas, about the middle of the country, about the West. So being able to use local resources really matters, and bringing the right technology to make use of local resources is the way to explore. So the most important thing you can bring to Mars is the ability to use local resources and live off the land.
Really neat. It's pretty refreshing to see a map of the U.S. in shades of blue and red. It's been a long time since I've stared for hours on end at anything like that. So if you get there, hopefully there's some stuff there that helps sustain you so you don't have to take it all with you, such as water.
Absolutely. So water is the most important resource for exploration. Water is amazing. You can drink it. You can crack the hydrogen and the oxygen, H2O, into rocket fuel and oxygen to breathe. You can use water to protect your settlement. Water is a great radiation absorber. So that, remember, dry, salty, radiated environment, water is going to keep astronauts safe. And the question is, where is all the water? We think about Mars as being a cold desert planet. I told you a couple minutes ago that it was like Antarctica, and that you could look out on the surface and all you would see would be dry rocks and dust and sand blowing around. Turns out we've caught Mars at a really, really boring time in its history. Right now, if you look at Mars in the sky, and you absolutely should, because it's a bright, big orange dot up there right now, you'll see that Mars doesn't have a lot of ice at the surface. All the ice is crammed into these tiny little polar caps that are clinging to the poles of the planet. But between about 500,000 years ago and 2 million years ago, Mars's orbit tilted. And when it tilted, the sun warmed up those polar caps and spread that ice over the entire surface of the planet down to about 30 degrees latitude. So if you can imagine snow in Austin, and I know it happens sometimes, but if you can imagine an ice age where snow is always falling from Austin all the way up to the North Pole, that would give you a sense of what these ice ages looked like on Mars. And this was enough to cover the surface of Mars with a meter or more, so 3-4 feet of ice. And so this is kind of like, putting icing on a cake or cream cheese on a bagel. This is a thick deposit of ice that is mostly still there. Mars's orbit is tilted back, and that ice has started to sublimate away. So it doesn't melt. It turns right into a gas and heads back into the atmosphere, and then heads back to the poles into these cold traps. So is any of it left? Well, for a long time, folks thought the answer was no. But the neat thing is, geologists who are experienced at looking at landscapes that form in cold polar deserts were able to look at some of the high-resolution images of Mars that are coming from orbiting spacecraft. These are high-resolution images like from the HiRISE camera on Mars Reconnaissance Orbiter. And when you look in detail at the Martian surface, you can see clues, you can see evidence that there's actually a huge amount of ice still there. And that's what future explorers are going to need to get access to. So maybe we can zoom from this kind of orbital view down to the surface. And what you'll see is that we're looking for landforms like those that form in Antarctica. So we're looking for rocky surfaces that have cracks in them. There's thermal contraction crack polygons where the ground gets so cold so quickly, but it's ice, it's glued together with ice that it cracks. And so you should see that rough, bumpy surface is all cracked, just like the permafrost, the frozen ground that I showed you in Antarctica. And what you can see here is that when the HiRISE camera flies over the Martian surface, you can actually see places where that ice is peeking out. This is basically like a giant ice cream sandwich on Mars. There's the rocky surface of the planet. There's the ice that formed about 1 million years ago that fell out mostly as snow and was compacted and mixed with the dust. And then at the top is another crust layer. And that crust, is not a chocolate cookie, bummer, It's ice, it's sand and dust and rock that was mixed in with that ice. And as the ice sublimates away and goes back into the atmosphere and back to the poles, it leaves that dust behind. And that dust is really great. It's a wonderful insulator. So if you've ever, used a pot holder to pick up something hot, having a nice fluffy big pot holder keeps your hands safe, keeps heat from moving from the pot to your hand. Well, this dust does the same thing. It preserves that ice under a nice insulating layer, and it's pretty much there for future explorers to use. The only thing that you really need to access this ice, if you're a future explorer on Mars, is a shovel and maybe a water bottle. And then what we do in Antarctica to keep things thawed is you just sort of stick it in your parka in your armpit, and that ice will thaw in no time. That's a great thing to drink. Maybe a little bit grimy, but the ice is there. Just that heat and humans.
Wow. Oh, so that is a significant resource waiting to be exploited on that planet. Wow. There is some recent breaking news about finding traces of water on the moon. Why is that important? Should we be going to the moon instead of Mars for our extraterrestrial water?
The only fiercer battle between geologists than chocolate versus vanilla ice cream is moon versus Mars, and they're both great. That I'm strongly pro ice cream in all of its flavors, and I'm strongly pro all the planets. But the moon is really interesting. It's an airless body. It has no atmosphere, and so there's not a lot of water on it. The big discovery over the last couple of weeks from the Sophia Observatory, which is this airplane-borne telescope, kind of amazing, is that there's actual water molecules that are mixed in with the rocks on the moon. So instead of having like a layer of ice, like the ice cream in an ice cream sandwich, this is actually rock with water kind of glued into it. And these water molecules are there, they're real, but there's not a lot of them. In fact, you would have to scoop up a cubic yard of moon soil and heat it and squeeze it and vacuum evaporate it and then condense it all out to get less than a pint of water. So there's a lot of treatment that has to go into this rock to be able to drink it, right? In general, no one drinks rocks. People would rather drink ice or water. Whereas on Mars, the same kind of geology happens. There are water molecules stuck to the rocks in the glass and in the mineral grains, but there's about 100 times more. But more importantly, there's also that buried ice. So, I think it's a possible resource for future explorers, but learning how to drink rocks is a real technical challenge. Whereas on Mars, the ice is there. We know it's there. We've seen pictures of it, and we know it's more than enough to sustain a really big Mars base and a future Mars community, and maybe enough to support any Martian microbes if they're there.
This stuff just blows my mind. This is really cool. Thank you, Joe. Are you up for some questions?
Absolutely. I would love to know what folks want to know. Ask me anything.
I think we have some questions from online here. There's a lot of people on YouTube and Facebook watching this. And I'll just say a shout out from Rocio Britos. She says, hello from Argentina.
Wow, hello.
So far, Rocio, you're winning from watching the furthest away. So let's start. This question comes from Brian. He says, do you think after 3 months, astronauts will go crazy from the confinement and quote unquote bad weather?
That's a great question. I think that astronauts are going to need to be really good roommates. I think right now a lot of people are at home and they're with their families, they're with their roommates. And after a couple of months of quarantine, everyone is feeling a little bit stir crazy. And so, I think future astronauts are going to feel the exact same thing. But I think it's going to be worth it for them after, 3, 6, or even 9 months in transit to have that experience of going out onto another world. And so I think they're going to need to be patient. I think they're going to need to be team players, but they're also going to need to be accustomed to being inside, right? You can't just walk outside on Mars. You need insulating gear, you need air, you need a pressure suit. And so they're going to spend a lot of time indoors. So while I got into geology because I wanted to be outside and to study our planet and to be out in nature, future astronauts are going to spend a lot of time indoors. And I think they're going to really cherish those opportunities to go outside.
So in a way, you're saying what everyone's going through around the world in the pandemic and this shutdown, we're all sort of a little bit going through astronaut school.
We are all training for the next Mars mission. I think if you pass the sign-up sheet, a lot of people would sign up.
Well, oh, we have Vandana saying hello from Pune, India. So
Oh, wow.
now there's a new leader in the clubhouse who's watching from furthest away. Okay, let's go. And so,
with all these international watchers, I just wanted to say this is an incredible time for international Mars science. There are missions going to Mars from several different countries. Scientists all around the world are working together and sending different instruments and different spacecraft. And it's just a really exciting time. But everyone, I think, around the world agrees that exploring is exciting. And so it's wonderful to see folks online and sharing in the excitement.
Yeah, really neat. Brooklyn Jade asks, what would you say is the most difficult obstacle we would have to overcome to live on Mars?
Brooklyn, good, Jade, good question. It depends. Let's see. I think a lot of people are worried about really kind of scary sounding obstacles like radiation. And so there is concern that because Mars doesn't have a magnetic field to speak of, the same strength of Earth, it doesn't have an atmosphere to protect us from cosmic radiation, that astronauts are going to be exposed to a lot of radiation, and that's bad for your cells. So there's a lot of concern about how humans can burrow underground or maybe even burrow into that buried ice and have safe places to live that are shielded from radiation. But as a geologist who really loves mud and tiny rocks and sand and dust, I gotta say it's the dust that worries me the most. If you've ever kind of opened up a bag of flour and the dust has gone everywhere, the experience of what a Martian explorer is going to experience. When they take their spacesuit out onto the Martian surface and dust starts blowing around, it's going to get everywhere. It's going to be even worse than flour. It's going to be like glitter. It's just going to get into everything, into every seal, into every pump, into every corner of the habitat. And that dust is bad for machinery. It scrapes, it breaks down seals, and it may be bad for people's lungs, right? We're all worried about lung health right now, and tiny particles getting into astronauts' lungs from Martian dust is going to be a real hazard. So I think, we're going to come up with clever ways to deal with it. We're going to wash it off. We're going to use static, electricity to zap it to the ground, and we'll probably be okay. So I think none of those obstacles, radiation or dust, is insurmountable. But it takes some great partnerships between geologists and engineers to make it safe for humans to be on Mars.
Very interesting. The next question comes from Katerina, and actually one's coming from Carolina as well. They're very similar. Let me read them both together. Are you worried that current climate change on Earth and current sustainability practices will make Earth just as inhabitable as Mars currently is, so people will have no option but to expand there? And Carol follows on with, is going to habitate Mars a better option than salvaging Earth?
That's the nice thing about being a geologist, Katerina and Carol, is that you really learn to love our planet even as you explore other planets. And so, I think that exploration of Mars shouldn't be seen as an either or. It's not, either take care of the Earth and learn to live with our environment and manage it, or go and explore Mars. I think, everything that we learn about exploring other planets, about how to kind of bottle up the really important things from Earth and Earth's life support systems, and knowing how the oceans and organisms and plants and the atmosphere and humans all kind of interact and allow each other to live, is important, right? Engineers are looking at how Earth's biosphere sustains life so that we can kind of put it in a capsule and take it to Mars. And so there's lots of thinking that some of Earth's biology is going to be involved in exploring Mars and in keeping air clean and water clean for future explorers. On the flip side, everything that we learn about taking care of humans when we're so far away from home on another planet helps us better manage our planet, right? So the more we can think about, how human-induced climate change is going to affect all those life support systems for our planet, right? Climate, oceans, precipitation, the better stewards we're going to be of this planet. So I think, the Earth has been through a lot, and humans have only experienced a teeny tiny bit of Earth's variation in climate over time, and we're used to what we live in, right? We like our conditions the way they are now, and it's going to be a struggle as we change climate to adapt and survive. But I think the same ingenuity that humans are taking to living on to exploring other planets and learning to live on them, we're going to be able to apply to keeping our life support systems going here. So I'm not, signing up for a one-way trip to Mars anytime soon. I still would bet on humans and Earth, but I think it would still be exciting to go.
I appreciate your optimism. That's important. I'm going to couple of other questions here together. Sarah asks, how long will it take for us to colonize Mars? And Ethan asks, would it be possible to terraform small aspects of Mars with the current technology we have?
Awesome. So, Sarah, the first question, how long would it take to colonize Mars is an interesting choice. Settling on another planet, the first mission to Mars might be just a few people, might be 3, 4, 5 people. It's possible to send more. There are ambitious private programs like SpaceX that want to bring dozens or hundreds of people to Mars, kind of in every trip. There's a lot of people on Earth. Our population here measures in the billions. And so for thinking about how long it would take to settle Mars, remember that it's a long trip, and every kilogram of mass, every pound of stuff that you bring, whether that stuff is people or tools or life support systems, is expensive to bring. So I think Mars will always probably have a pretty small population, even going out decades or hundreds of years. My hope is that it's mostly scientists, or it might be people who are just fed up and want to leave this rock behind and go someplace else. But I think, the real lesson of the last several decades of Mars exploration is that the resources are there. There's enough water ice on Mars today to sustain a really large population. And especially if humans get good at recycling that water and not losing it to the atmosphere, then there's no real reason that thousands or tens or hundreds of thousands of people couldn't live on Mars someday. I think we're not going to run out of those resources. So I hope that people settle Mars. I hope that gives us a base to explore it better, to understand its evolution, and to look for signs of past life. So I guess I'm optimistic about that, but I think it's going to be a long process. As for terraforming, this kind of gets at that question that was asked before about, how do you make a planet habitable? And I think changing Mars's whole climate is really tricky, but everything that we learn about changing a planet's climate gives us more information to manage our own climate here. So the same kinds of problems that we deal with too much heat and too much energy in our atmosphere can be applied to Mars. It would be nice if Mars could absorb more sunlight and start warming up, and that would cause some of the ice in the polar caps to start moving around, to start falling as snow, make it a little bit easier to get. So the same kinds of things we want to not do for our planet, trap heat near the surface, wouldn't be so bad to do to Mars if you were trying to terraform it. So I guess my advice for future terraformers is to start small, to think of managing your base like a garden, and thinking about, can you make a small bubble of Earth, a small bubble of air, a small bubble of warmth before you go and try and modify a whole planet. I think there's a real responsibility to explore Mars as it is now, and not just make it a place for humans. But then once it's been explored and understood, then yeah, I think it would be wonderful if humans could live there. So I think that's a whole new kind of frontier for technology.
Yeah. So follow up to that, Josh asks, if we did find a place to land and we did determine all the livable arrangements, how far off are we sending people to Mars?
Oh, Josh, good question. The technology to get to Mars is basically there. Humans have the rocket technology to go. And what's really missing is the political or economic will. Going to Mars is a giant, expensive adventure. And it would really transform our understanding of how the solar system evolved, how life evolves on rocky planets, how rocky planets evolve. So we're there. We just need to get up the gumption to commit the resources to go, to commit the rockets, to commit the ice mining tools, and to commit the astronauts who are willing to take on the risk to go. So it could, right now, in the latest opportunity to send anything to Mars, we've sent a whole bunch of robotic explorers. Could we, in the next opportunity, in 2 years, send a human crewed spacecraft? If people were in a hurry to build one, we could go. Sometimes Mars missions kind of feel like electric cars or flying cars. They're always 5, 10, 15 years off. But look, now we have electric cars. We're here. We're in the future. So I think as soon as people get together and commit, whether through national space programs, through international space programs, or even through private space exploration companies, I think we could be going. We just need the will.
So Straya asks, they have these rovers that are exploring Mars. Do they take them down to Antarctica, like to try them out, make sure they're going to work on the terrain and everything, and in those conditions?
Some, yeah. So a lot of rover testing happens in hot deserts. Outside of the Jet Propulsion Laboratory in California, there's the back lot where rovers can be put through their paces. But there are experiments that NASA organizes in Antarctica. And there are robotic systems that are tested, not so much on land in Antarctica, but there are robot explorers that have been tested in Antarctica's ice-covered lakes, sort of like swimming robots for icy moons. There's a real desire to make sure that a robot that you're designing for a cold, inhospitable place can survive there. There are teams that try and do simulated missions in Antarctica who try and kind of use radios to communicate and practice extravehicular activities. Kind of going outside of your habitat. I think there's a real hope that we can do more mission testing in Antarctica in the future, maybe developing robots that can explore icy cliffs or climb debris-covered glaciers or even drill into that ice, which is going to be an important technology. And so there are things that Antarctica is special for, that really only exist there. This extreme cold, this extreme dryness. And so it's important, I think, that more testing happen using that environment. Because it's the best way to be absolutely sure that things are going to work when you get to Mars. Right.
So Zhu asked a question that has been, a lot of people are asking, but I'll ask it from Zhu's perspective. Actually, it's Tony from Austin. How do we ensure that we don't mess up Mars like we've messed up Earth? And other people are asking, how do we make sure that when we explore Mars, we don't exploit it?
Yeah. And I think that's a really important question. Some people talk about colonizing Mars, but colonization has a terrible history on our planet. And so I prefer to think of us as coming to live on Mars and coming to live with Mars. We're lucky that there is no resource on Mars that is so valuable that people are itching to go to get it right now. And that's an impediment to exploration. But it's also one thing that keeps Mars safe and keeps it pristine and as a wilderness. I think the question about past and sort of deeply buried or subsurface life on Mars, both of those questions have not been answered. And the biggest risk that we can take going to Mars is that we will mess up future scientists' ability to know whether life ever evolved there or if there is a deep hidden underground biosphere. And that's because humans are gross. We carry microbes with us. We sneeze. Everyone is very aware of the microbiome of our planet right now, right, in pandemic time. And so no matter how good your seals are, no matter how good your spacecraft are, some of that is going to leak out into the Martian habitat. And so the risk is that you're going to contaminate the surface. And then when you go out looking for life on Mars, you're going to find it. But at the risk of being gross, maybe it came from humans, maybe it came from someone's sneeze. So how do you prevent that? Well, you build really good spacecraft that don't leak. You build really good spacesuits that don't leak very much. But maybe you take an attitude like our national parks, right? America's best idea was to preserve some places in our country that we really value and that are really important and that are preserves set aside for science or for wilderness. And so I'd like to see some areas of Mars that are just off limits to humans and that are places that are going to be explored by humans and robots working together in a very sterile, very clean way so that we don't mess up that planet entirely.
Great thoughts, Joe. We have a minute left. I'm going to offer a comment more than a question that's Elizabeth puts forth, and then 2 rapid fire questions. All right, strap yourself in.
All right, I'm ready.
Elizabeth says, I will never go to Mars if I can't bring my cat and my 2 dogs and my horse. Never, capital letters. All right, so Elizabeth, thank you. Are you ready for a tough one, Joe? Here it comes.
I'm ready.
Challenge. Are there any minerals on Mars that aren't on Earth?
Not that we know of, but the only minerals that we no, not that we know of, I think. But there are minerals on Mars that we only know about because we know about extreme environments on Earth, like Antarctica site.
Yes, exactly. That question came from Nicole. The last question comes from Divya. What is your favorite thing about being a geologist?
My favorite thing about being a geologist is doing science outside. I love science and I love being out in nature. And when I found out that there was a whole field of science dedicated to Earth and its environment, I thought this was like playing for work. It's great. It makes me so happy.
Joe, thank you so much. I know everybody joins me in thanking Joe for joining us. You could find more info about Professor Levy's research and a full-length talk, chock full of more cool Mars stuff. Just go to hotsciencecooltalks.org, hotsciencecooltalks.org, or to find out more specifically about Dr. Levy's research, you go to www.coaldirt.org. That's not joedirt.org. That's cold dirt. That's not Joe's Martian.dirt.org. That's coaldirt.org. Dr. Levy, thank you so much for joining us.
It was a pleasure. Thanks to everyone for tuning in.
Yeah, have a wonderful evening. Goodbye from Hot Science at Home.